So we'll do some demo series circuits here. This first one, as I mentioned, is pretty basic. First thing we want to do when we're doing these is fill in the given values. It's disheartening sometimes when I'll see somebody will get the wrong given values and then their answers are off. So we're given 6 ohms, 4 ohms, and 2 ohms. And we're given our voltage, so we don't want to forget that. We want to use units, get in the practice of putting those units on the end so that we know what it is we're talking about. First thing we're going to want to do is find our total resistance. For that, we add up the resistors. We just add up our resistors. Pretty straightforward. 6 plus 4 is 10, plus 2, 12 ohms for our total. Then we find our total current. Our total current is voltage divided by resistance. Well, that's going to be 24 volts divided by 12 ohms. Gives me how much current? Anybody? 2 amps. And what do we know about current in a series circuit? It's the same everywhere. So we can fill in that whole column now. So then we just need our individual voltages. Well, E equals I times R. We know our resistances, we know our currents. So 6 ohms times 2 amps is 12 volts. 4 ohms times 2 amps, 8 volts. 2 ohms times 2 amps is 4 volts. 8 and 4 is 12. 12 and 12 is 24. We can check our number both ways because it should add up this way and it should multiply across this way. Power, P equals I times E. So now we just need to take our current that we found and our voltage that we found and multiply them together to get our power. 12 times 2 is 24. This is watts. 8 times 2, 16 watts. 4 times 2 is 8 watts. And then 24 times 2 is 48 watts. So we know that they multiplied together this way, and now these should also add up. 16 and 8 is 24, 24 and 24 is 48. So we can fill out these charts and be very confident that our numbers are correct. So I'm going to move to the next one here. And I'll bounce around a little bit, but first thing I'm going to do is fill in my given values. R1 is 100. R2 is 200. R3 is also 200. And our voltage is 10 volts. Now, with what we've learned about series circuits and resistors, oh, I forgot my ohm sign. Mr. Horkey's going to dock me points on that. Just kidding. If R2 and R3 are the same resistance value, what's that? The amps is the same everywhere, true. But what can I say about the voltage? The voltage is, they're going to be the same. Since the current's the same and the resistance the same, they're going to be the same. So before I even start banging away on my calculator, I can know that my voltage in R2 and R3 should come out the same. So what do we get for a total resistance? 500. I guess I could have did that one in my head. I didn't hear any calculators clicking on this one. 10 volts divided by 500 ohms. 20 milliamps. And you'll hear me say this a million times. What do we know about current in a series circuit? It's the same everywhere. So I fill in my chart here. So now my individual voltages, I'm going to multiply resistance times current to get my voltage. 100 ohms times 200 100 ohms times 20 milliamps, 2 volts. 200 ohms times 20 milliamps, 4 volts. And then the same one, 200 times 20, 4 volts. And then again, we can check this. 4 and 4 is 8, plus 2 more is 10 volts. So we know that this number is good. Our power, P equals I times E, 2 volts times 20 milliamps, 40 milliwatts. And then that's one thing to notice. Using our prefixes, we do want to make sure we know how to enter them in the calculator. But when we start working with them more, we're going to start recognizing things like here I have milliamps times a base unit. Well, my answer is going to have to be a milli something. Here it's milliwatts, because it can't be 20 times 4 is 80. Well, it can't be 80 watts because my current's so small. So 20 milliamps times 4 volts, we get 80 milliwatts. Again, these are the same, R2 and 3. So we're going to have the same current. And now 20 milliamps times 10 volts. 20 milliamps times 10 volts is, anybody? 200 milliwatts. Well, if I add up 80 and 40, I get 12 plus 8. So these add up, as well as, what's that? Never mind. Oh, sorry. We'll fix that 80. Now 80 and 80 and 40 is 200, so they add up this way. We multiply it across, and our numbers are good. Keep going? All right, we'll do the third one. The third one is a better representation of the type of circuit you might see if you did have to check something out on a circuit board or piece of equipment in the field. Because resistors are generally in kilo ohms. They're generally not, like I said, sometimes they're small. So first thing we want to do is fill in our given values. R1, 2.2 k ohms. One's kind of hard to read here. 2.2 k ohms. 2 is 3 k ohms. And 3 is 4.7 k ohms. And our given voltage is 36 volts. So when we add these up, anybody? Are you punching them in? Take your time. How much? 9.9 kilo ohms. And that's pretty good ballpark. 4, 5, 6, 7, 8, 9. And the other values. So now our total current is the next thing we'll find. So find total resistance, find total current, find individual voltages of your resistors, and then verify with power values. So our total current is 36 volts divided by 9.9 k ohms. And what do we get for that one? Total current, yep. 2.64, thank you, sorry, 3.64 milliamps. And what do we know about current in a series circuit? It's the same everywhere, sir. Feel like a drill sergeant, but very important. Current's the same everywhere in a series circuit. Individual voltages, we multiply across. 2.2 k ohms times 3.6 milliamps. What do I get for our 1 volts? 7.92 volts. R2, anybody? $10.2 volts. 10.92 volts. I hear the calculator keys punching, so I'll give you a second. You get R3, holler. $17.1 volts. So before I even add them up to verify, since R3 is my largest resistor, it should have the largest voltage value, and it does. That goes to those proportions we were talking about before. R1's the smallest resistor, and it has the smallest voltage. So at first glance, our voltages look pretty good. If we add up 17, 27, 34, and then the rest comes out to 36 volts, we can be confident with that, with those voltages. So now we'll multiply to get our power values, and I'll let you guys do some punching. If anyone has any of them, just holler it out. For R1, 28.5, and what kind of amps? Or watts? And milliwatts, yes. Because we multiplied with a milli, our answer is going to have a milli. R2, 39.7. $39.3. It's pretty close. And small errors of rounding are acceptable. Generally, if we're within 10%, is acceptable because our resistor tolerances are usually 10%. For a straight calculation, they should be pretty small differences, but it just depends on where you round it. 61.5 milliwatts. Matt, you got the total over there? 131 milliwatts. And that was a straight multiply across. 3.64 milliamps times 36 volts. So then when we add, we should get the same thing. Ballparking it looks pretty good. So we can be sure of our numbers by double checking them. And this is everything we could need to know about a series circuit. Resistance values, current values, voltage values, power values. This exercise didn't get into if you're missing. Sometimes they'll give you the total resistance, and then one of your resistor values is missing, so you have to piece things together. This exercise didn't do that. The practice problems in your book do that. Those are very good to brush up, especially before a test or a quiz, because with the tables of practice problems in your textbook, the answers are in the back, so you can check your answers. If you do the first 4 or 5 and you're getting them right, you can be confident. If you're getting some of them wrong, that gives you a chance to verify, make sure that you're up to snuff. Up to snuff. All right, thank you.